Welcome to our CCPS Science Review Lab. I've got a question. What are some of the units of measurement that we use every day? Can you think of any? Maybe you can think of feet or inches. Maybe you've been working with the metric system, so you've been working with measurements like centimeters or millimeters or kilometers. I have a question for you. Are days and hours and weeks, are those units of measurement as well? Of course they are. They're how we measure time. So suppose I ask you right now, being an 11, 12, or 13-year-old, if you would rather figure out how long you've been alive using days or years, which would you rather do the computation for? Well, obviously years, right? Because it's way easier to say and figure out, well, I've been alive for 12 years or 13 years than to take those 12 or 13 years and multiply them by 365 days. Scientists came up with a similar situation. When they were talking about some of those huge distances that we see in outer space, they had the option of working with really, really, really big numbers or creating new units of measure that would make their computation and their understanding much clearer. So when we look at, say, the distance between the Earth and the Sun, we know it's about 150 million kilometers, or the equivalent, which is 93 million miles. Now, go ahead and try to use those numbers in computation, and it becomes very cumbersome or bulky very quickly. So what scientists decided is they were going to create a new unit of measure. And in this case, it was going to be the astronomical unit. 1 astronomical unit equals the same average distance between the Earth and the Sun. So instead of using 150 million kilometers, it enabled scientists to use 1. If something were 2 times the distance that it is from the Earth to the Sun, it would be 2 astronomical units. 5 times the distance the Earth to the Sun, 5 astronomical units. So it allowed scientists to reduce the bulkiness of their computation. Well, as we got a little savvier and our technology improved, we started to be able to see things and understand things that were even further away. And scientists then came up with the measurement unit of a light year. A light year is about 9.5 trillion kilometers. It's the distance light travels in 1 year. So light travels about 9.5 trillion kilometers a year. So that way, if we were talking about, say, the North Star, everybody's looked up at the sky, they've seen the North Star, Polaris, that's about 320 light years from Earth. So scientists could measure and multiply with 320, or they could say 320 times 9.5 trillion kilometers and work with that number. Obviously, that number would be super bulky. So that's why scientists came up with the idea of these different units of measure, both astronomical units and light years. Now, we know that Mars is about 1.5 astronomical units from Earth, okay? When you think about that and how far that is, what do you think some of the challenges might be when we're trying to explore Mars? Show me what you know.